I'm working on DCOS, but I'm not talking about DCOS in special. Really, a topic that, yeah, I got into and really interested in really trying to spread the word, getting you motivated for that. And the idea there is essentially not always doing motivation slides, but I think it's worth it in this sense, or in this case. Why, ask yourself, why does the automotive industry spend millions of dollars per year crashing thousands of wonderful cars on a regular basis? Because they want to find out what happens in extreme situations. And for them, it really makes a lot of sense to invest that money to, crash these cars under controlled circumstances to understand what is going on there. There are many more examples there, but I think crash tests are probably the most widely known ones. Now, ask yourself, why are you not doing it with your infrastructure, with your containers? A lot of people think, well, my code is bug-free, right? Been running in production for half a year, whatever. That's cool. It does cost time and money, right? Remember, the cars, that's real value being destroyed there, but usually or typically the outcome, the insights that they get there are higher than what you invest there. And it certainly falls into a category of work that's, as writing documentation or whatever, is considered uncool. You're not really creating a new feature or deploying something new. You're destroying stuff. I hope that by the end of the talk, you have enough motivation to at least consider applying the one or other technique I'm showing you here yourself in your infrastructure. So let's work towards a kind of framework how we get there. If you take that spectrum from development to prod, I'm pretty sure you're familiar with things like unit testing and integration tests. You might be familiar with property-based testing. That's the insight that it really sucks to manually write unit tests, right? So you essentially describe the desired properties. For example, if you say you have a function, let's take that serverless example again, that adds two numbers, then you would expect that the outcome, for example, is higher than any individual one if both are positive. In property-based testing, you essentially generate a lot of them automatically, and you can very easily figure out edge cases. Fault injection being another example where you deliberately induce these edge cases. You got smoke testing, stress testing, load testing closer to production. You got canary deployments, and I'm going to focus especially on this resilience testing, which it's scary, I take that, but happens essentially in production. Two more notes on that. One thing that I came across, I didn't actually find the source anymore, but someone claimed that the increased uptake and coverage in terms of unit tests comes from the fact that people are using interpreted dynamic languages increasingly, like Node.js or Ruby or whatever. So what in a compiled language like Go, that's probably one of my favorite languages nowadays, would have been caught by the compiler at compile time, you're essentially kind of compensating for with unit tests in these kind of languages. The second comment on this one, and I mentioned it already before, it is a kind of cost-benefit calculation here, analysis there. So for example, take the case where you're doing unit tests, depending on the language you're using, versus you're doing canary deployments. When you figure out, and maybe that's more appropriate for a startup environment, but if you figure out that it is faster and better to expose a new version of a service or whatever to a small population, and you figure the problems there, then writing these unit tests, then by all means, you do that, right? So you need to be certain that the time, and with that, the costs, developer's time or whatever, you invest there, really, get you some benefit at the end of the day. With respect to containers and container orchestration systems, we have essentially three main scopes that we are looking into. It is the host, most typically, especially in the cloud, it would be a virtual machine, and then things that are going on between different hosts. Because at the end of the day, you're ending up in a distributed system, right? So increasingly, if you're running containers, you probably have more than one machine you're running these containers on. So networking, I'll get back to that in a moment, is really a big part of that. Then you've got the level of the containers themselves. We'll get back to that in a moment as well. And then you have to think about the service itself, so things like the application or service-specific things like, I don't know, served requests per second or whatever, and also business metrics, I don't know, number of transactions you can do per hour, whatever. Not all of these levels are equally easy to test and to cover, but it's worth it to be aware of where exactly you are in this stack. One of my favorite things out there, I think fellow Peter Deutsch from Sun put together, are these 8 fallacies of distributed computing. And who of you is not aware of these? That is an awesome sign. So unless you're sleeping, this is really great. So I don't have to go into that in greater detail. The question is, do you really, like, you've heard about that, do you really pay attention to that? Let me look at a certain example there. For example, the network is reliable. Usually, the modern container orchestration systems are perfectly capable of abstracting away certain things, but in certain situations, you really have to understand what's going on if you have split brain or whatever, especially with stateful stuff. So ask yourself, looking through that list, are you actually paying attention to that? Are you proactively testing these things to an extreme? Now, chaos engineering itself, the term, was kind of introduced by Netflix when they moved their infrastructure to AWS. And this is not about, randomly damaging your infrastructure. You're not taking out your sledgehammer and running around, or whatever the equivalent would be in the cloud. But this is a kind of scientific approach. So you have to look at your system, your microservices, your whatever you have there. You define the expected behavior based on the metrics you have there. Let's say the requests per second served, or users, or whatever. Then you define your expectations. You say, all right, if, I don't know, a quarter of my machines goes down, I expect the system to do that, or whatever your expectations are. And then you actually test these hypotheses, right? And compare with your expectations, and by that you should figure out what exactly, on whatever layer you need to tweak things, has gone wrong. So again, it is really a scientific approach to testing and not randomly damaging infrastructure. So let's have a look at different failure modes. And what I tried here is to kind of abstract away from concrete container orchestration platforms like Kubernetes and Docker Swarm and Marathon and so on. You pretty much have, in all of these different systems, you have masters, typically one active master and some standby, and you've got worker nodes, right? That's where the actual work is carried out. And each of them has a number of containers there. So you can already see, thinking also about the scopes earlier on, where are the different places where you can essentially start in a constructive manner to destroy your infrastructure and formulate hypotheses around that. Let's have a look at an example. Let's say you've got 3 masters, and the active master, you kill, for example, the active master. So you say, for the time it takes until a new master is elected, I expect that all of the running tasks are continue to run, if they are long-running tasks, and I want to be able to submit or create a new service or task within 5 or 10 seconds. The same is true for on the worker side. So if you have, for example, Docker that depends on a daemon sitting on the worker node, what happens if an entire node is taken out, or the daemon, or one of the containers, and so on. And again, not to forget the network partitions that can happen here, especially, as I said, for stateful stuff where you have replicas flying around and you need to figure out what happens. Can I still write to a database? Will my data still be available? And so on. Some aspects I like to highlight here in this context to show you a bit what to pay attention to. The basic thing, and that should not be very, very surprising, I believe, is automation, right? Obviously, you want to have an automated testing environment. You don't want to manually, once you have established your expectations, manually test these expectations and see and compare them with the outcome. One basic thing that, again, nowadays pretty much all of the container orchestration systems support are health checks. They come from low-level stuff like looking at the exit status of a shell script or whatever over TCP, over HTTP, where they essentially say if a certain endpoint /health or /status or whatever returns 200, HTTP code 200, then you consider this service or this container healthy. Be aware of that. This might sound trivial, but if your container contains something a bit more complicated than a simple stateless service, then these health checks can actually be quite hard to write properly. Because what, for example, for a database, what does it mean that a database is healthy? To a certain extent, you can treat containers a bit like black box testing, and you can ask yourself, what happens if you cut off the connection to the environment locally or, as I said, within a network setup? A couple of dimensions you can look at and establish your expectations there. Disk I/O, you could, for example, simulate what happens if the disk runs low on space. Time skew, that's one of the things that sometimes is kind of overlooked, but especially, again, with stateful services, very troublesome. And that is that potentially on each of the different nodes or workers, the time is slightly different, and over time actually gets worse. The network traffic, already mentioned that. You can simulate between single containers or one-on-one, or between entire groups of containers, what happens if the network either decreases or entirely, for a certain period of time, stops working. And things like, low-level things like requests per second served, probably one of the easiest things to monitor, to get an insight in. You also have to ask yourself, what about cascading failures? So you have one container that, for example, generates some random sequence for indexing or whatever. That might be stateless, but downstream it might, in one way or the other, affect a stateful service. So think holistically, think not only testing certain applications or certain replicas, but really an entire request path, for example. One thing I really would like to highlight and point out, it's important that you don't underestimate the work to get into testing stateless stuff, but especially for stateful services, this is something where you probably need someone who has a better understanding of what is going on with the respective database that you're using there in the context of containers. We get to tooling in a moment. So now let's ask ourselves, how can you actually apply all these things? And good news is there are some tools. The not so good news is that I would guess in any given case, you would probably still need some engineering muscle. You still need some effort. You need to put in some effort to actually make it work. So obviously, as I said, Chaos Monkey kicked off the whole thing there with chaos engineering. There are a number of resources around there. essentially killing off virtual machines in AWS. Someone was nice enough to put that into Docker with some instructions around that. That's cool. There are approaches like Wekamp did, essentially combining, gamifying the whole thing, combining that in their case with Half-Life 2, others suggested Doom or whatever. Essentially, they are testing their microservices infrastructure with that, and you get a nice view of how certain services are killed and hopefully resurrected. There are things like Boomba that allow you to do chaos testing or resilience testing on a per container level. Mitsuru and Blockade are especially great for the network layer to make sure that you really test how the communication between different containers goes. Correct me if I'm wrong, if someone like Craig or whoever knows more. I have only seen within SIG testing this one issue there, so there is an issue, but I'm not entirely sure. I haven't found a tool yet out there. And I've put together a little tool for the open source project I'm working on that's called Frags, and that's the thing I'm gonna give you a quick demo on, if everything works out. Yeah, that looks okay. Okay. So let's maybe start at the beginning. So this tool, which has the wonderful name of DCOS Resilience Automated Xenodiagnosis Tool, which obviously is a reverse acronym, so Drax was there before, essentially uses the Marathon API, and in a sense it's decoupled, and you can easily rewrite the whole thing for Kubernetes or Docker Swarm. You deploy it, and once it's deployed, you can essentially do two things or three things with it. You can ask for the current stats, so how many of the containers have been killed, and you can either kill containers throughout so irrespectively of the application, or you can target a certain application. So the setup I have here is I have a DCOS cluster here with some 4 nodes, and I have Drax deployed. That's just a one-liner. Oops. So Drax is running here and hopefully serving. Right. Okay. And then I've got 2 applications there, dummy application that just sends hello world to stand it out, and an Nginx web server. And if I'm now looking at the stats, so I've done already one run, killing 3, and then have a look at the rampage file. So one one iteration would be 1 rampage, and you define essentially a certain level, and the application you're targeting at, in this case, dummy. So that's the ID if you want a distributed PID for that application. And then you essentially provide that to the rampage endpoint. You say, okay, go ahead. Not sure if we're fast enough. Oops. Already there. Okay. Okay. Let's see the stat. Yeah, 6. So default would be, you can also specify the number of instances you want to kill. So in the default configuration would be 3. And since I have 20 running there, that would be fine. Depending on who is gonna carry out the test, this might be run by system or cluster administrator that just in general checks all the containers that are running independent of who belongs, who is responsible for them, or a certain developer or DevOps role that looks after his or her specific application. As I said, written in Go, very simple to extend or use with other container orchestration systems. The only thing you need to be able for now is effectively to say kill a number of containers in the scope of a certain application, and that's the only place where different container orchestration systems have a certain notion of what a application or service might be. Okay. I mentioned earlier on already, stateful services are an area where, on the one hand, you need quite some expertise, especially with distributed stateful services. Could be things like NoSQL databases, Cassandra, or distributed message queues like Kafka or whatever. And thankfully, Carl Kingsbury here has put together Jepsen and has done quite a lot of analysis himself already and provides some services around that. And so my advice would just be, if you have any kind of distributed service in your containerized application, then strongly advise you to have a look at Jepsen or hire Carl if you can't do it yourself. It's really worth it. He put quite some effort into making the whole thing work, and also the interpretation of the results is quite awesome. Put together a couple of resources to, if you're interested in that topic, if you want to learn more. Probably the best book, not necessarily specific to containers, is the Resilient Engineering in Practice guidebook. If you, again, as I said, stateful services being one big part and one area where you need to probably invest a bit more time than with stateless stuff. Guy from Foundation DB gave a wonderful talk at Strange Loop talking about that topic. And last but not least, my former colleague Tyler, big shout out. We had a lot of discussions in this space, and he motivated me to do more in that area. And again, he's available for hire. If you want to get his advice in that topic, feel free to reach out to him. All right. Okay. Thank you. Cheers.